The future of renewable energy technologies is advancing at an unprecedented rate, driven by the need for efficient, long-lasting and widely accessible energy sources. Innovations in solar, wind, hydro and geothermal energy are making significant strides, while newer approaches such as fusion power and advanced energy storage are gaining traction. With improvements in efficiency and scalability, the global energy landscape is shifting away from traditional fuel sources and embracing the potential of cleaner alternatives. As researchers and engineers refine these technologies, they are unlocking new ways to generate power while ensuring reliability and cost-effectiveness. Solar power remains a key pillar in renewable energy, with improvements in photovoltaic cell efficiency and new materials like perovskite enhancing energy conversion rates. Traditional silicon-based panels are becoming more efficient, while thin-film and flexible solar cells offer lightweight, portable solutions. Concentrated solar power systems, which use mirrors to focus sunlight and generate heat, are expanding energy storage options by converting thermal energy into electricity. Breakthroughs in solar panel design allow greater integration into urban environments, with transparent solar panels embedded into windows and solar roofs, providing power directly to buildings. Wind energy is evolving through enhanced turbine designs and new offshore installations. Vertical axis wind turbines offer advantages in urban environments, while floating offshore wind farms are expanding energy production potential. Advances in blade aerodynamics and turbine efficiency allow modern wind farms to generate more electricity while reducing maintenance costs. Offshore wind power benefits from consistent wind speeds, and engineers are developing deeper water installations using floating platforms. Smart wind farms, equipped with sensors and AI-driven optimization, can dynamically adjust turbine angles to capture the most energy while reducing wear and tear. If you're enjoying this future technology video, please like and subscribe. Thank you. Hydroelectric power, one of the oldest forms of renewable energy, is undergoing modernization with smaller-scale hydro solutions and pumped storage systems that enhance grid reliability. Traditional dams provide consistent power, but their environmental impact has led to innovations in run-of-river and underwater turbine technologies. Low-head hydroelectric installations allow energy generation without large reservoirs, reducing habitat disruption. Pumped storage hydroelectricity acts as a large-scale battery, storing excess energy by moving water to higher elevations and releasing it when needed. Geothermal energy is tapping into deeper and hotter underground reservoirs, expanding its potential beyond regions with natural geothermal activity. Enhanced geothermal systems inject water into hot rock formations to generate steam, allowing energy production in previously untapped locations. Supercritical geothermal technology, which extracts energy from ultra-hot fluids, promises higher efficiency and power output. The expansion of direct-use geothermal applications such as heating and cooling systems for buildings is increasing its adoption. As drilling technologies improve deeper, geothermal sources will provide reliable, round-the-clock energy without reliance on surface weather conditions. Energy storage is becoming a crucial factor in the widespread adoption of renewable technologies. Battery advancements, particularly in lithium, sulfur, and solid-state designs, are improving capacity, charging speeds, and lifespan. Grid-scale storage solutions like flow batteries and sodium-ion batteries offer alternatives that reduce reliance on scarce materials. Beyond batteries, compressed air and gravity-based storage systems provide additional ways to store excess electricity for later use. Hydrogen storage is also emerging as a solution, with excess renewable energy used to generate hydrogen that can be stored and converted back into electricity when needed. Fusion energy, often regarded as the ultimate power source, is making progress with experimental reactors and new containment techniques. Unlike traditional nuclear fission, fusion generates minimal waste and relies on abundant hydrogen isotopes for fuel. Advanced magnetic confinement methods, such as tokamaks and stellarators, are improving plasma control and energy output. Laser-based fusion, which uses high-energy pulses to initiate reactions, is also showing promise. If commercial fusion power becomes viable, it could provide nearly limitless energy with minimal environmental impact, revolutionizing the global energy market. Artificial intelligence is optimizing energy generation and distribution by forecasting energy demands, managing smart grids, and improving efficiency. AI-driven algorithms analyze weather patterns to predict solar and wind output, allowing better integration into energy grids. Smart grids, which dynamically distribute electricity based on demand and availability, are reducing energy waste and enhancing reliability. Machine learning is also streamlining the maintenance of renewable energy systems by detecting issues before they cause failures. These advancements are making renewable energy sources more stable and adaptable to real-world energy demands. Bioenergy is gaining renewed attention through advancements in algae-based fuels, biomass gasification, and waste-to-energy technologies. Algae can produce biofuels with high efficiency while absorbing carbon dioxide, making it a promising alternative to fossil fuels. Biomass gasification converts organic materials into synthetic gas, which can be used for power generation or converted into liquid fuels. Waste-to-energy plants are reducing landfill waste by extracting energy from organic and non-recyclable materials. As bioenergy processes become more efficient, they are offering additional pathways to reduce dependence on traditional fuel sources. Tidal and wave energy are emerging as reliable sources of power due to their predictable nature. Underwater turbines harness ocean currents, while surface-based generators capture wave motion. Innovations in floating energy platforms and oscillating water columns are expanding deployment possibilities. The consistency of ocean energy allows it to complement more variable sources like solar and wind, providing a stable energy supply. Researchers are developing materials and designs that improve durability and efficiency, ensuring these technologies can withstand harsh marine environments while delivering consistent power. Superconducting materials and advanced electrical transmission systems are reducing energy losses and enabling long-distance power distribution. High-temperature superconductors allow electricity to flow with minimal resistance, improving the efficiency of power grids. Direct current or DC transmission lines are also playing a role in integrating renewable energy sources across vast regions. By reducing energy losses in transmission, these advancements ensure that renewable energy generated in remote locations can reach urban centers without excessive waste. The development of better power conversion technologies is further enhancing the flexibility of modern energy grids. The increasing affordability of renewable energy is accelerating its adoption worldwide. The cost of solar panels, wind turbines, and energy storage systems continues to decline due to improvements in manufacturing and economies of scale. Government incentives and private investments are supporting large-scale renewable energy projects, making them competitive with traditional power sources. As technology advances, the economic viability of renewable energy is strengthening, leading to widespread adoption across industries and residential areas. Continued research and development will further drive down costs, making clean energy accessible to more regions. The future of renewable energy is marked by constant innovation, expanding applications and increasing efficiency. From advanced solar panels and offshore wind farms to fusion power and AI-driven optimization, new breakthroughs are reshaping the global energy market. As energy storage and smart grid technologies improve, the reliability of renewable sources will continue to grow. With ongoing advancements in power generation, storage, and distribution, the future promises an energy landscape that is more efficient, resilient, and capable of meeting global energy demands without reliance on finite resources. Want more information about exciting future technologies? Like and subscribe to this channel. Please leave a comment if you can think of any good ideas you'd like to share with others. Thank you for watching.